skip number 19. Let's look at 18 first. All right, let's go and do this by hand. Nope, I said that wrong. Let's do this with our hands on the calculator. In parentheses, 4 times 10 to the power of 4. Get out of exponent mode. I push close parentheses. And why am I using the parentheses? Just because I want the calculator to know very clearly that I want this in order of operations, because the calculator is going to think order of operations. And in some cases, it may do it out of the order depending on how it's typed in. So I am using parentheses on this. Plus, parentheses, open parentheses, 2 times 10 to the power of 4. Now, the exponents are the same on this. That's not significant when we're putting this into the calculator. It gives me 60,000 right there. But we do want this in scientific notation. So I put the decimal between the first 6 and the 0, 6.0. You can just make it 6 times 10 to the power of 1, 2, 3, 4. And that's a positive 4 right there because the number 60,000 is bigger than 1. That's pretty crucial. Some of you guys are saying that we just took the 4 and 2 and added them together. Yeah, that's only the case when the powers of 10 are the same in scientific notation. If they were different, what you're going to end up having to do is change these, or at least most of the time people change these into standard notation and then add and then replace back into scientific notation. I prefer calculator method, which is why I did not discuss that before. All right, so that takes us through 3 operations: multiplication, division, and addition. Of course, subtraction. So let's do this one with our hands on the calculator. So open parentheses, 9.2 times 10 to the power of 8, close parentheses, minus open parentheses, 4 times 10 to the power of 8, close parentheses, enter. And that's what my calculator shows me. 5, 2, 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. You can put commas in there if you'd like. So that looks like 520 million. And remember the decimal for the black number there is right there, okay? But for scientific notation, it needs to be between the 5 and 2. A non-zero number in the ones place value doesn't matter about the decimals. And like we said before, it's no need to show all these zeros here. I suppose you could, but don't do it on the assignment either. So times this by 10 to some power. It's bigger than 1, so it's a positive exponent. How many place values are between the decimals? 1, 2, 3, 4, 5, 6, 7, 8. So we end up with the power of 8. And this would be our final answer on this one. Now I know up here it said do not convert to standard form. We're going to pretend like that wasn't there. So you're welcome to if you'd like. I mean, we did it right here, but again, that's a valid method if you do change these into standard form and then perform your operation and then change it back to scientific notation. That's okay. So that's crucial to understand, is especially when they're the same. We're saying that we're dealing with the same place value in scientific notation. It's just doing it in a different way. Like this would be 40,000 and 20,000. Well, you're dealing with the 10,000s here and 10,000s there, which only works, again, if the exponent for your base 10s is the same. If they're different, then you got to change them into standard form anyways and then operate. Or you can just type it into the calculator.